interfaces. There's one, and there's two. That's pretty nice because then when you take this little smaller one, you can push that in the actual module like you would this card. And then you will have two serial interfaces. And this one right here will be the cable that you use. These are called WIC 2T cards. So different type of interfaces are used to transmit your data from one side to the other. Obviously, if you're going to be using a serial cable on one side to plug into router 1, let's say you have router 1 sitting here and you have router 2 sitting over here. If this is a serial cable, you're not going to plug it into an Ethernet cable over here. You're going to plug it into what? A serial connection. Obviously, if I'm using fast Ethernet coming out of here, I'm not going to plug it into a serial connection over here. I'm going to plug it into a fast Ethernet connection. So each one of these, like a fast Ethernet cable, will have eight wires. So here's wire 1, 2, 3, 4, 5, 6, 7, 8. Someone has to do the transmitting. We'll have two cables that transmit. And then we'll have two cables that receive. So this is what we call a pinout. We call this a pinout because of the fact that we are using certain cables that are you doing the transmission and the receiving. We also have different type of voltage for this particular Ethernet. So you don't want to try to get plug into plug into a fast Ethernet connection and then try to change the pins and coming over here into a serial connection and try to make it work. You might be sending too much voltage into this card or vice versa and destroy the card or the interface. So if you have a WIC 1T on one side, obviously you're going to have a WIC 1T on the other side. If you have a WIC 2T on one side, obviously you're going to have a WIC 2T on the other side. As of now, if you want to actually find the adapters that go from a WIC, the adapters or the cables that go from a WIC 2T to a WIC 1T, that's fine. But for now, just think of it as serial in, serial on the other end. Think of it like that. And these are just different types of actual cables and modules that you're going to use and interfaces that you're going to use. Most likely, you're going to be using these or this one and fast Ethernet. Now, your console cable is really important too because this is the console port used by this console cable. It's what is extremely important for you to be able to log into the back of your devices. Every device is going to have a console port, and you need to plug into that console port in order to log into the device and get the information you want out of that device. And when I say information, it's more than just information. You're going to be using that as a means of making those routers and switches do exactly what you want. So our network devices also have these symbols that we kind of are going to start getting used to. As you notice, I was drawing a router. I drew a circle for a router. And I put an R in there, and then I'll have the router 1. If I'm connected to another router, I'll have a router 2. If I draw this symbol here, as you can see, here's my router. If I drew this symbol here, that means I'm using a serial connection, as you can see with the lightning bolt here. If I was going to connect to another router, say router 3, and drew a straight line, that means I will be using an Ethernet connection. So what does that mean? Obviously, if I have a lightning bolt, I'm using a serial connection, which means I'm going to be plugged into what? A serial port on this end and this end. If I have a straight line, that means I'm using Ethernet, so that means I'm going to be plugged into what? An Ethernet or a fast Ethernet connection. These are just names that you haven't really learned what they are just yet, but doesn't matter. You know now if I say, hey, I got a serial connection, you're going to know, okay, well, if I have a serial connection, that means I'm going to need a serial cable and obviously a serial port to plug into it. And if my router doesn't have a serial port, guess what? I can't have a serial connection. If the router only has one fast Ethernet connection or a port on its router, that means I only can have one other router plugged into me via Ethernet. Now, if I decide to plug router 1 into a switch, notice my square here is a switch. I would also give it a name like this, saying switch 1. And I would draw a straight line or a line like this, which is still a straight line. This is telling me that I have fast Ethernet here plugged in, fast Ethernet plugged in here. Now, your switches are always going to be fast Ethernet. So that means in order for me to plug a router into a switch, it can never be something like this, because switches don't have serial ports like that. Okay, does that make sense? Hub is something we're going to talk about, but not something that you're going to be using. If I was actually drawing out a hub, I would literally have this, and I would say hub 1. That's how I draw them. And eventually will be talking about hubs. But most of you will not need to have a hub in your lab. Put it to you like that. You will not need it. But we will be discussing how traffic moves across the hub. And of course, hubs are only Ethernet ports as well. Firewalls, never really in my course with CCNA. So you won't see those here. The bus, we'll talk about the bus a little bit, but not to the point of really needing, we're not going to be using it. And here's the cloud. The cloud we will be using as well. So let's talk about two things that, and also here's a bridge. We're not gonna be talking about bridges either. I mean, might have some, talk about some things about bridges, and that might not even happen either. But we will not. You will not see me be drawing this. These are the symbols you'll see me using all the time: Ethernet, router, switch, serial connection, and cloud. So let's talk about this idea of the cloud. A cloud usually symbolizes that we have a router that's plugged into a cloud, and over here is another router that's plugged into the cloud. Which means that this normally when you see this means we have either two routers sitting at the same site going into the internet, and we don't have any other, and no other idea where that traffic is going. We just know it's going to the internet. Or we have multiple sites that are going from one side to the other. So if I'm sitting here in Texas with a site and sitting over here in Maryland, over here at this particular site, this router belongs to me in my Texas site, right here, and this router belongs to me in my Maryland site. We control what? The router and this interface sitting on the router. We control this router and this interface going to this router. On the other side is a router that belongs to whatever ISP that we're using. We have no control with these routers, nor do we know how many routers and switches are in between to get from Texas to Maryland. We don't know, and the most important thing is we don't care. We really don't care how that traffic gets from this spot here over to this spot in this direction. No idea, and we don't care. So this is what the cloud symbolizes. It symbolizes that we don't really know what's going on in here. So we make this cloud idea, the idea that we can't really see through a cloud, and that's the concept of the cloud. So you will see that a lot, but in most cases it's going to be site to site like this, or this both of these could be Maryland sitting in the same building. So that means both of these routers are sitting right here, plugged into a switch here, plugged into the same switch. And what we're symbolizing here is the fact that we're at the same site, same building. We got redundant routers. We got 2 routers to move our traffic. And this traffic is, these routers are hitting the internet. We have no idea. We don't have any other sites. And we might even set this up like this and have another router up here. Router 3, which is in Texas. So that means we have site-to-site communication from Texas and Maryland, and our Maryland site has 2 routers going to the internet, where this router has 1 router going to the internet. But when you usually have this type of setup, we say it's going to the internet, but we're really not trying to communicate with internet traffic per se. In our world, and when I say our world, I mean the network guy or the network girl, or the network man and network woman, they will be considered with the communication between this router and this router. We call it site-to-site communication, because you're trying to communicate with your Maryland site and your Texas site. Now, let's talk about what we call a logical diagram. This is very important because you won't see me do this often, but you'll see documentation do it. So, if I have a router and it's plugged into a switch, and I have another router that's plugged into this switch here, and let's say I have a PC sitting here, and let's say I have another router sitting over here, and he is coming into a switch, and here's a PC sitting here. These switches are normally means that we actually have this interface, and this interface on the same network. Now, when I mean interface, obviously the interface is sitting on the PC, but you also have it plugged into a switch interface. So I just put it right here in the middle. Same thing here. I mean, we got 2 interfaces here between each link. So if this means ideally that they're on the same network, instead of drawing out the switch, sometimes what they'll do is this. We'll have a line drawn like this. And then we'll have a line drawn out like this. So you'll see this a lot. What this means, we call this... Now, when you say a lot, you won't see it a lot in my course, but you will see it a lot in documentation. We call this a segment. So think of this segment as a network A, network B type thing. Everyone on this is on the same segment, which means they're on the same network, which means they're plugged in physically to the same switch in some fashion. Because this is our logical diagram in that fashion. Now, you're asking me right now, well, why would you do that? Why not just draw the switch? Okay, so let's say You're plugged into here, you're plugged into here, and you're plugged into here. And these switches are plugged together. Would you want to draw out switch 2 and switch 3 and switch 1 every time? And all these are on the same network. There'd be no need to. So to make it simple, I can just say router 1, router 2, PC1, here's the cloud. We can have this router go out, this router go out, and everyone is on this segment here. Okay? It makes it easier for my diagram. I know for a fact that all these are on the same segment. It gets some getting used to, but ideally this PC is not just plugged into some line that's going across. It has to be plugged into something. And what do you think it's plugged into? A switch. I mean, that's it. In order to get more than 2 devices connected on together, we have to have it on some type of device, right? And that would have to be a switch. So those are things that I really wanted to bring to attention. You will see that in your documentation. Most likely you will not see that in my course at all, but it's possible. So these network symbols are something you need to get used to. Just keep, eventually they'll come to you. But the router, the switch, the cloud, the serial connection, Ethernet connection means something. When I draw those symbols, it means something. You know how I'm connecting them. So how do we fit all these things together? Now notice, whenever I want to hook up multiple devices, more than 2, I'm going to have a switch. All of them are connected to a switch. This allows PC 8, 5, I think I got 8 in there twice, so that might be 6, but either or. And 7, I think that's 6. PC 6, 5, 6, 7, and 8. It allows all these PCs to communicate with each other. It also allows them to communicate over here with network A. Why? Well, let's talk about that. If this router wasn't here, and this is the only connection that we had, that means even this wire is not there, PC 5, 6, 7, and 8 can communicate with each other. But they can't go any farther. So that means if I wanted PC 1, 2, 3, and 4 to communicate with these devices, I would have to plug them up to this switch somehow. Then all of them can communicate. But what if I didn't want them all on the same network? What if I wanted PC 1, 2, 3, and 4 on a different network? Well, I would come over to here, put them on a different switch. Doesn't mean you always have to do it that way, but in our example, we have a different switch.